Welcome. In this video we are going to be exploring fractional index laws. A fractional index is basically having a power which is in form of a fraction. For example, if I had 5 to power a third, okay, like we been discussing in the previous lessons, 5 is my base, but this time my power or the index is a fraction. So what laws are there that deal with fractional index laws? If a, let me use an example, if a is an integer and it is to power 1 over n, this is the same as having the nth root of a. In our previous lesson, we talked about how to determine nth root of a number without using calculators. Just a very brief recap. We mentioned that, for example, if I'm required to find the fourth root of 81, I will let it be equal to a number r. This means that r to power 4 equals to 81. In order to determine r, I'm going to write 81 in the form of a number to power 4. So I do this by prime factorization. So after prime factorizing, I should have 3 to the power 4. It means that my r equals to 3. So the fourth root of 81 is 3. So this is how we do this number in case the question is in the form of without using a calculator. So back to this index law, if I have a number to power 1 over n, they are basically asking me for the nth root of that number. For example, this is another example. If I have 49 to power a half, the question is basically asking me for the square root of 49, which is 7. Or if I have 27 to power a third, they're basically asking me for the cube root of 27, which is a 3. Excellent. Now, the other index law or the other rule, if I have if I have a fraction power, is if I have a, where a is an integer, to power m out of n. Okay, this is going to be the nth root, like we saw, nth root of a, everything to power n. So it is like considering, it's how does that come about? It's me considering a to power 1 over n into power n. So from the previous index laws we looked at, this is the power law where you get to multiply a to the power 1 over n times n, which brings you to that. But I know that my 1 over n is the nth root of a and everything to power n. So for example, if the question required me to find 27 to the power 2 out of 3. So this is the same as getting the cube root of 27 and then I square it. Okay, so we already know how to get the cube root of 27, which is a 3 squared. It's going to become a 9. Okay, so remember, just a brief summary, that if I have a to the power n over n, the denominator becomes the nth root and becomes the whole power. Please don't forget that. So now, what if our question involves a negative? Let's take an example of 32 to the power negative 2 out of 5. Okay? Now we need to remember what the negative does to the number. Okay? We say that the negative on the power flips or gives you the reciprocal of the number. So this is going to become 1 over 32 to the power 2 out of 5. My power stays the same, but I've gotten the reciprocal of 32, or I've flipped 32. So then I follow the same rules. So this is going to become 5th root of 32, that is 1 over, and everything squared. Now we know how to calculate 5th root of 32, and that is 2. So this is going to be 1 over 2 squared, which is a quarter. Okay, so that's how we evaluate expressions using the fractional index rules. Brief recap once again. The fractional index rules are: if I have a power 1 over n, that's the nth root of a. And if I have a to power m over n, that becomes the nth root of a, everything to power m.